we discuss the importance of building reusable launch vehicles to achieve rapid reusability in space exploration. This is wasteful, and that's why scientists have dreamed of building reusable launch vehicles. Most of you focused on the filter blockage, which happened during Flight 3. Or the upcoming Starliner launch instead. But doesn't that work against the ultimate goal of rapid reusability? SpaceX's Starship is a type of rocket designed to turn that dream into reality. And its Raptor engine is a holy grail that makes the reuse process more efficient than anything from any other company. Join us as we delve into the concept of SpaceX's Starship and how it aims to revolutionize space travel through reusability. Learn why this innovation is crucial for the future of space exploration. Let's explore together the dream of reusable launch vehicles becoming a reality. So in today's episode of AB Space, let's explore how a major change in the reusability of SpaceX's Raptor engine is shocking competitors like Blue Origin and even over at NASA. The Raptor engine is a beast that has been developed over the past decade. After many iterations, it's currently one of the most impressive rocket engines in the world. Each engine can generate 500,000 pounds of thrust equivalent to one of the main engines on NASA's retired Space Shuttle or the Space Launch System rocket. Not only powerful, but SpaceX's Raptor engine is also unique with its remarkable reusability. As Elon Musk has stated, each engine needs to be capable of flying up to 1,000 times to support the ambitious operations of Starship. Indeed, this is a huge challenge. There's no engine in the world has achieved this. The most reused engine in space exploration history is the main engine on each space shuttle, each of which only flew a dozen times. However, this does not seem to be a difficult issue for SpaceX, as they always set bold goals and strive to surpass them with all the capabilities they have. Don't forget that today, they have set a record for reusing Falcon 9 booster up to 21 times. Even though SpaceX's initial plan was only for 10. Having said that, I'm not sure whether Starship can achieve 1,000 flights in the near future. If it does reach full potential, one day 1,000 flights might be within reach. That alone would be a remarkable achievement. To achieve multiple reuses of the Raptor engine, SpaceX had to integrate a series of technical factors across different aspects of the engine to ensure it can fully leverage the advantages of a rocket engine in ways that other rocket manufacturers have not been able to do. The first aspect we must discuss is SpaceX's intelligent use of fuel. Initially, SpaceX uses LLX, liquid oxygen, and RP-1 fuel from Merlin engines of the Falcon rocket series. This is a traditional method that most previous rockets have employed. However, for the Raptor engine, SpaceX chose to replace RP-1 with methane. At its core, it is similar to other engines, burning chemical fuel to produce thrust, but using liquid oxygen and methane, a first in the rocket industry. And its innovative design means it's SpaceX's trump card in their determination to achieve rapid engine reuse. The change from RP-1 to CH-4 was made because of a process called coking. Each Merlin engine must be thoroughly cleaned before it can be reused. Why? Have you ever lit a tiki torch and watched a black smoke rise from its kerosene dipwick? Now, imagine a rocket burning thousands of pounds of this stuff. Italy is an enormous amount of solid carbon matter behind, which is fine with an expendable single-use engine, but not so great if you want to reuse that engine. If unchecked, the soot will continue to build up and eventually cause major problems. Of course, SpaceX is not the only company switching to methane. Their competitor, Blue Origin, led by billionaire Jeff Bezos, is also developing their own methane engine called the Blue Engine 4B4. With numerous benefits, this shift has been overdue for quite some time. One advantage of using methane is its higher efficiency compared to other fuels, meaning rockets can be smaller. Lower costs also mean that the overall launch costs can get reduced. This is crucial given the large number of Raptor engines that SpaceX plans to manufacture. Each Starship vehicle is designed to fly with 6 Raptor engines, along with 33 engines on the Super Heavy booster, a total of 39 per launch. SpaceX's largest rocket to date, the Falcon Heavy, launches with 28 Merlin engines, 27 on the lower stage and then 1 on the upper stage. With the number of launches SpaceX is planning for Starship and Super Heavy, The production rate will need to increase significantly. The second aspect that makes the Raptor engine one of the most efficient rockets ever built is its advanced rocket engine technology. Merlin is an open-cycle gas generator-powered engine. The LOX-1 and RP-1 are burned inside a gas generator and are shot out of the diverging nozzle, launching the rocket skyward. What makes Merlin open-cycle is that all the fuel is not fully burned inside the combustion chamber, but gets thrown away or dumped, so it's not a wholly efficient system. Such an engine has two independent pumps for oxidizer and fuel spun by two turbines powered by their own dedicated preburners. But unlike the gas generator cycle, which burns just a small amount of fuel and oxidizer in the preburner, in a full-flow staged combustion engine, all the fuel and oxidizer is run through their respective preburners. In other words, the fuel gets burned twice. Once at a lower efficiency in the preburners to produce energy for spinning the turbines, and again at max efficiency in the combustion chamber to produce thrust with what Musk says is 99% efficiency, or the maximum allowed by physics as we know today. While an exceptionally difficult engine to design and test, it completely eliminates the waste of the gas generator cycle. But increased fuel efficiency isn't the only advantage of this design. For example, the seals separating the turbine and the pump are less critical, as there is no concern of contaminating the pump liquid. Ultimately, they're going to the same place. In addition, the fact that the fuel and oxidizer enter the combustion chamber as gases further improves engine efficiency over conventional designs, which spray them in as liquids. The individual turbines on a full-flow staged combustion engine also tend to run cooler and at lower pressures than the single turbine used in a conventional rocket engine. This puts less stress on the turbine impellers and should allow them to run longer before they need to be inspected and replaced. Given SpaceX's focus on reusability, this is likely seen as just as important as the increased fuel efficiency. Honestly, the concept of reusing engines or rockets is not new in the aerospace industry. But few have been able to achieve what SpaceX has. Even the largest space organization in the US, NASA, has not yet been able to make reusable rockets. Why? Well, first, NASA isn't really in the rocket development business. NASA only gets involved in rocket building when the commercial market doesn't have a product that can fulfill their needs. But the answer is quite simple. NASA doesn't use enough rockets to make reusability worthwhile. Reusable rockets are only valuable if the frequency of launches is great enough to outweigh the cost of developing and utilizing the technology. It would have been soy to waste Apollo project funds trying to make the Saturn V reusable. Only about a dozen launches of the Saturn V ever planned, so it was cheaper to use a disposable launch vehicle. When it came time for the space shuttle, NASA did plan to do many frequent launches, so the orbiter and solid rocket boosters were designed to be reusable. It wasn't deemed worthwhile to make the external tank reusable. Although the space shuttle main engines, SSME, were reusable and going to be used on the SLS rocket, NASA doesn't plan to reuse them. The refurbishing and recertification costs make reuse more expensive than just making new engines. The French and the Russians did at one time work together in an attempt to make the Ariane V reusable, but the hardware that would be needed to support the return of the vehicle became too large to make that effort worthwhile. Making a launch vehicle reusable is quite difficult. It took SpaceX 14 years to do that first part. It was a large investment form and it required modern technologies that did not exist when most of the current launch vehicles were being designed. Even today, with SpaceX having partially demonstrated the technology, some of the launch vehicle manufacturers are still not convinced that it'd be worthwhile for them to invest in their own resources in their upcoming vehicle designs. Let's discuss the implications and details of the upcoming hot stage ring jettison happening on Flight 4 of the Starship Super Heavy. In SpaceX's latest blog post on the Flight 3 report and upcoming changes for Flight 4, they mentioned upgrades derived from the flight test will debut on the next launch from Starbase on Flight 4. as we turn our focus from achieving orbit to demonstrating the ability to return and reuse Starship and Super Heavy. The team incorporated numerous hardware and software improvements in addition to operational changes, including the jettison of the Super Heavy's hot stage adapter, following boost back to reduced booster mass for the final phase of flight. So what is meant by hot stage adapter jettison? Before directly addressing that, let's go back to Flight 2. After Flight 1, SpaceX introduced the concept of hot stage separation for the Starship Super Heavy to increase the efficiency and payload capacity of the spacecraft. In this method, most of the 33 Raptor engines on the Super Heavy booster are turned off, but a few remain firing when the engines on the Starship upper stage are ignited. This avoids the loss of thrust during traditional stage separation, where the lower stage shuts down first. The hot stage separation involves the Starship firing up its own 6 engines to push itself away from the Super Heavy booster. To make this method safe for the booster, an additional ring section was installed on Starship's interstage to direct the blow of the engines. This method could potentially increase Starship's payload to orbit capacity by 10%. Now, why do they want to jettison this additional ring section? I think this change is part of a broader effort to reduce the mass of the Super Heavy booster. A fully fueled booster has a mass of up to 3,500 tons. After liftoff, the mass reduces as the propellant is used up. During its return phase, it would barely have the fuel for the boost back burn and landing. As you know, for the Falcon 9, SpaceX mentioned that they only keep the fuel necessary for the same process. This is done to reduce the mass of the rocket as much as possible. This same principle applies to the Super Heavy booster too. But additionally, if they could remove some more mass that significantly doesn't contribute to the landing process, isn't it good to remove that? Of course it is. That's the reason why they are jettisoning the hot stage adapter. By jettisoning, SpaceX aims to minimize the risk of potential difficulties during landing and maximize the chances of successful recovery and reuse with improved control over the booster. The HSR ejection will occur shortly after the boost back burn shutdown process. So how much does this additional portion weigh? My best guess is that it weighs around 10 tons. You may be wondering if this could cause a mass discharge and affect the entire mass distribution. Of course there will be an effect, but SpaceX will try to balance that with the propellant or any additional measures. Another big question that revolves around is whether they had jettisoned the HSR for Flight 3. To call a rocket entirely reusable, we have to recover and reuse all the significant and costly components, such as the first stage, second stage, payload bearing and control systems, etc. This is because some components, like fuel and protective shielding, are typically expendable and not designed for recovery. In this case, I strongly believe that this decision to eject the hot stage ring is a temporary measure, while they work on a more advanced design for the ring section that can be retained throughout the mission. For the meantime, for Flight 4, the HSR ejection will be a critical step in achieving a successful landing of the booster in the ocean. So, that's all about the hot stage ring ejection process. I hope I was able to give a simple but clear idea of how it works and why they are doing it. I will get into this deeper after Flight 4, so make sure that you have subscribed to our community, where crucial things like these are first discussed. Moving on to the Flight 4 upgrades. SpaceX has made an official announcement regarding the upcoming Flight 4 of its Starship program. The Flight 4 timeline will closely resemble that of Flight 3, with some key differences. After stage separation, the Super Heavy booster will conduct a boost back burn, followed by the HSR ejection. The Starship will then re-enter the Earth's atmosphere, flip, and perform a landing burn. Notably, Flight 4 will not include some of the activities that were part of Flight 3, such as opening and closing the payload bay door and space burns and propellant demonstrations. Instead, the focus will be on demonstrating the ability to return and reuse the Starship and Super Heavy. SpaceX has also announced a specific launch date for Flight 4, June 5th. While this date is still pending regulatory approval, it aligns with previous statements from Elon Musk and the company. The preparations for Flight 4 are underway, with the Starship S-29 and Super Heavy B-11 already distacked after completing the wet dress rehearsal test. The teams have conducted final checks within the last 2 days. And now the ship is almost ready to be stacked atop the booster. That's all about today's SpaceX Starship update. And that's about it for today's episode. Thank you so much for tuning in, and that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to my channel and hit the like button. And if you want to support our channel and if you want to be up to date, you can become an exclusive member, so click on our perks through the link in the description below. Thanks to watching and see you next time.